Hi, Cammy.
Hi.
Okay, there we go. Hi, Angie, Cammy. Here we go. Okay, we did the warm up. What did we do? We did the last prom for warm up. Here we go. Oh, Sebastian. Yeah. Hope you're watching, listening at home. Okay, don't throw up. Okay, here we go. Now, yeah, I feel like Frank Sinatra here. So, strangers in the night. So, logistics, real quick. I really don't need to do that. Logistics. First, about the test, the AP test. Do you understand the format of the test, or I need to talk about that real quick?
Yes.
That is an oral question.
Talk about it, please. Yeah, talk about it.
Okay. All right. So here you go. The AP calculus exam has a total of 108 points, equally divided between free response and multiple choice. The free response is pretty clear. It's 6 questions, 9 points each. 3 of them are AB, 3 of them are BC. Okay? The multiple choice is 45 questions. Now, in order for them to be weighted equally, obviously they'll need to multiply that by a factor of 1.2.
1.2.
Yeah. Okay. So each question on the multiple choice is multiplied by a factor of 1.2. 45 questions times 1.2 is 54 points. They're equally weighted. You with me so far?
Yes.
Okay. Now, in terms of how I will grade this, it varies from year to year depending on the difficulty of the test. But a typical cut score for a 5 is 68 out of 108. That's ballpark about 62% for a 5. Ridiculous. Okay? Now, in terms of the grade in the class, if you get a 5 on the test, then you'll guarantee yourself a B or better on the final. I will give you a B if you get what I consider a weak 5, which would be somewhere like between 68 and 78. Okay? If you get a strong 5, 79 or above to 108, then that's an A, call that scale. Okay? Yeah. The highest I've ever had on a mock exam was a 105.
Who did that?
I still cannot, John, his name is John Stewart. That's what I know. John Stewart's not that John Stewart. But John Stewart, yeah, he's a Caltech. He's like really smart. But that was about 8 years ago. Something like that.
I'm going to get a 108.
Okay, so that's the spirit. Okay, now, in terms of format of the test, first, okay, if you are taking the class, the final Friday, it'll be in my room, starting in 7th period. But if you're taking the class, the final on Saturday or Sunday, it'll probably be in Mr. Slaughter and Mrs. Weber's room. You're going to come in those doors. I'll be able to see you through the window, and I'll let you in. And then, yeah, that's it. So, in terms of time format of the questions, that's the where, the when, the how much. Please get here about 5 minutes ahead of time, please, so I can get you situated and get you BC in these rows and AB in these rows. You'll be in the same room, but the format is 60 minutes to start with. There are 30 multiple choice, no calculator questions, which obviously comes out to a budget of
2 minutes a question.
2 minutes per problem. It depends on you whether that'll be enough. Most people, probably 80% of the people, find that is plenty of time. There's some people that push it right up to the budget. But you would really have to be getting locked into one problem for one at a time. You'll probably will have enough time. Okay. Then, yeah. Then right after that, you go into calculator multiple choice. You have 45 minutes for 15 calculator multiple choice. On one level, that seems counterintuitive. You have more time per question, 3 minutes per question in calculator, but it's because it takes time to put stuff in your calculator, change the window, and all that stuff. That's why. Now, that is rarely a time issue. I've never had somebody run out of time there, except it was the case of one kid whose calculators and degrees, and they were freaking out, and they left. Okay? I have told you all year, hey, make sure I'm not doing that anymore. If you come up to me and say, hey, I don't understand, I'm going to say, I can't help you. I'm sorry. I cannot help you.
Okay.
Okay? Yes.
There's actually a degree unit in calculator.
Oh, yeah.
So you can be in radians but still use degrees.
Yeah.
Yeah, it's
A
cool.
degree
Wait,
unit?
yeah.
Yeah.
Like it's next to the pi button.
Really?
Yeah.
And there's also a radian.
Yeah, so it's like reverse.
Oh, well, perfect. I need to, now it's probably not the time, but I definitely like to learn about that. Cool. Wow. Something I need to.
Coach can.
Oh, cool. Oh.
He has been learning. He has been
Oh, I do that all the time. That's my favorite.
Wow, that's awesome. Okay. All right, so back to the, come back to me people here. So after that, you'll have a 10-minute break. It's pretty common with AP Exam 2. Then you have 30 minutes to do 2 free response questions with your calculator. After that, you put your calculator away, but you may keep those 2 questions and work on them later. And you get the 4 no calculator free responses. There are 2 calculator, 4 no calculator. So in essence, a third of the test is calculator, 2/3 is no calculator.
Is the calc questions, are they usually like AB or BC?
It can vary from year to year, but it's pretty common this year.
Oh.
Okay, that's the test. These questions on the test. Okay, come over here, please. Next week, you know the AP testing schedule. That's pretty common. But let me talk about the final schedule, or seniors especially. Next Thursday. Okay. Next Thursday and Friday, we will be on a block schedule. 1, 2, 3 on Thursday, 4, 5, 6 on Friday, and you'll have a set of period on both days, all right? The periods are about 1 hour and 40 minutes long. And then on the next week, Monday and Tuesday, which are your last 2 days, they're also block schedules 1, 2, 3, 4, 5, 6. The reason is both to accommodate senior finals and math testing. So that's the deal. Now, let's focus on 2 weeks from yesterday. 2 weeks from yesterday. What? What the heck? Okay. All right. Hey, so AP Bike is going to be going on 2 weeks next Tuesday. Now, obviously, maybe not. All right. So that day, you'll have the AP Calc test in the morning, and after a little bit of lunch, you'll probably be coming to my class. Well, we'll have nothing to do really, so we'll go outside or whatever. But, however, if you missed, either you missed your finals periods 4 and 5 in the morning, then you could go to that class, Mr. Baker's class, or whatever 6th hour to take if he has it. Or if you want to arrange with them to take their final, either if he's giving the final this day, or if he's giving the final this day, and you want to say, hey, Mr. Rickman, can I go take Baker's final on Friday instead of coming to your class? That's fine. Okay, you're going to be missing their class because of my test, so that's fine with me. Okay, next week it'll be pretty light. It'll be going over the mock exam, what you did right, what you did wrong, where we can improve. There won't be homework that week. I expect a lot of absences next week, obviously, because of the AP test, so it'll be pretty light. All I ask is that if you are one of those people with 1 million AP classes, please don't take my final on Friday this week and not do a single calculus problem for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days. That's not good, okay? You'll be taking the test and say, what's the power rule again? Okay, so,
Over the weekend, so I don't know.
all right, are you with me, please? Do a little each day. If you have an AP test those days, check in and say, what do we do today? All right? Okay, so we talked logistics. Here we go. Notes, are you ready? Crazy. All right.
I didn't ask her.
Okay, so here we go. You can see the focus of this review is motion, yes? Okay. All right, couple things. First of all, in Calc 1 you do one-dimensional movement, whether it be along a horizontal number line or just vertically. In Calc 2, you do two-dimensional movement. That might be parametric equations or vector value functions, horizontal and vertical position vector, right? You with me?
Yep.
In Calc 3, you do three-dimensional calculus. That's easy enough. Now, I want to emphasize to you, first of all, I'm talking to you AP Physics people. It'll say clearly on the exam, just in case you get confused, this is an AP Calculus exam, not AP Physics exam. And it is calculus teachers reading your exam, not AP Physics teachers reading your exam. So if you're thinking along the lines, well, this is how we do it in physics, you're doing it wrong. Okay, do it with calculus. That's what they expect to see. Are you with me? All right, then. Yeah. Okay, so I understand you have great physics knowledge, but I understand they expect you to see calculus. There is obviously tons of overlap. Here we go. Velocity is sign change of position over time. For example, velocity is positive if velocity is positive, then you are moving right or vertically up. Again, I'm talking about physics, people. Don't give me that. It depends on how you define your axis. Positive is right, up is positive, period. You know what it is. It is what it is. All right. Average velocity. It can be defined found two ways. What's one way you could find average velocity? Which is change in position.
Just seek it slow.
Seek and slope. So we could take change in position between 2 points. Now, that would be handy if we had position. Okay? What if we had, what's another way to find average velocity? Average value of velocity. You could also do 1 over b minus a of the integral of v dt, or v of t dt. This would be if we had v of t. Are those different?
Yeah.
They're not different because if you integrate v, what's the antiderivative of v? It's x. It is, I know they look different. Sorry, what I meant to say is they're not really different at the core. Do you agree? All right. So let's talk details. Do you agree instantaneous velocity in one dimension, velocity is the derivative of position, one dimension. In 2 dimensions, velocity could be, let's talk velocity vector. Isn't that just the derivative of the horizontal position and the derivative of the vertical position? It's just the same as the derivative, but in 2 dimensions instead of 1. No big deal. You agree? Okay. Or parametric. It could be a vector or parametric. And there's 90% overlap, right? Say, for example, this is for a couple different reasons, but say I gave you this position vector with horizontal and vertical position. I think we all know horizontal comes first, right? If I gave you a velocity, or asked for the velocity vector, the velocity vector at time 1, then what's wrong with this person's work? They say, okay, the velocity vector, that's the derivative of x and the derivative of y. Here we go. Boom. Okay.
Placement of the t equals 1.
All right. So one problem is they're bleeding general and specific at t equal 1 is all mixed. I beg you to be safest. Would you just say, here's the velocity vector at any t in one step, and then in a second step, now here's the velocity vector at 1. That'll be easiest for them to give you point for. Their rubric will say, finds velocity vector at any time. And then their second point is, finds the velocity vector at 1. There it is, boom, 2 points. Okay? Don't bleed general into specific. They're looking for that. They go off of that. Notation is a big part of calculus. All right, what's the other mistake that's kind of subtle?
T squared.
Yeah. Derivative of 2t cubed is not actually 6t, it's 16. Where? I didn't really intend that. I didn't really mean for that to. So, you with me? Derivative, the derivative thing.
For,
Yes.
Vectors, like it's wrong to use X instead of P because of the.
Oh, yes. Absolutely. If you named a position vector x, they will absolutely.
Okay.
Because there's a horizontal one. Yeah, good point. That's a good question. Okay. All right. This is a mixture of the relationship of acceleration to velocity and initial condition basics of calculus. I'm giving you acceleration and an initial velocity. What's one way to find velocity using the initial condition? Integrate an indefinite integral and a plus c. Okay, so there is one big problem I've been having with students. This goes to, again, this probably goes to a physics component. What's the antiderivative? 1/2 t to the fourth minus e to the t. Here's the problem. I sometimes get people say plus c, and some people say plus v initial. True? Dead wrong. You just lost a point. That is not true. Okay? No. The constant of integration is velocity initial only in the smallest number of cases, like gravity problems, not in all motion problems. That is not true. Okay, not always. Darn right. Okay, that is not true. In fact, I can prove it's not true. If you plug in the condition 2 equals 0 minus e to the 0 plus c, what is the c? It's not 2, it's 3. Okay? The initial velocity is not the constant. That constant is something else that can come up differently depending on what the function is. Please don't say that. Okay? All right. Also, please don't make the very common mistake. I'm talking very common mistake of, oh, if you put 0 in, everything goes away. Not true. You know that's not true. When you put 0 into some things, it does not go away. Cosine, exponentials, all right? All right, what's another way to use the initial condition besides indefinite integral and finding the plus c? Definite integral and fundamental theorem. Okay, so for example, you could say v at t is the initial velocity v at 0 plus from 0 to some t. Now, if I am using t there, I use a dummy variable. What should I use? A at x. I'm not crazy about. Why not? It could be position, so it's probably safer to use u something, whatever u. I don't know if I use c. Let's just go u. Okay. Q, sure, use Q. Go for it. 2. Okay, now it feels like, wait a second, over there we got a 3, but over here we're getting a 2, but you can see that same e to the 0 yields a constant 1 that adds to that, and so they do end up the same. You with me? All right, so there are 2 ways to use an initial condition.
Should it be 0 minus e to the 0?
Yes, sorry, it should be, you're correct. Thank you, yes. I got the order wrong. Okay. Will you write yourself a note? Never use this approach on a Leibniz derivative. Leibniz derivative, use separation of variables. Okay, I'm talking a 5-point mistake on an AP test. You just dropped yourself to a 4
Wait, how
if
are
you
you
make
gonna
that.
do that?
Separation of variables problem on a differential equation, that's usually 5 points. And if you don't show separation of variables, we'll be-
No, but how would you even like do that?
So, good question. Yeah, I'll give you an example tomorrow when I do differential equations.
Oh,
Okay, it does, you think, why would anybody do that? But it really does happen.
oh.
Okay? Acceleration is the sign change in velocity. So if it's change in velocity over change in time, then one way to calculate average acceleration is change in velocity over change in time. That would be if velocity is known, yeah? But as always, you could get average anything if you have the anything. You could use average value of A if acceleration was known, right? Okay. This goes to what I was saying there. Be careful not to assume constants. The constant integration is initial anything. Bad math. All right. Now, acceleration, wouldn't you agree, in vector form in 2 dimensions is the second derivative of position horizontally and vertical? Yes. I'm trying to get both 1 and 2D as I go. Okay. Speed. Speed. Let me go over here. Speed in 1 dimension. What's speed? Absolute value of velocity, okay? So think of speed as remove direction. Okay, conceptually. Now, in 1 dimension, removing direction is easy, absolute value. In 2 directions, how do you say, I want to know how far is it? Okay, it's Pythagorean theorem. I don't care how fast it's moving horizontally. I don't care how fast it's moving vertically. I just want to know how fast. And so the speed in 2 dimensions is the Pythagorean theorem. Like that, yeah?
Yeah.
Okay. If they're asked, is speed increasing or decreasing? This goes to, they're picky about how it's worded. Right, Ty? Right. How do you word speed increasing?
If velocity and acceleration are the same size.
Speed is increasing if velocity and acceleration are the same size. Okay. Oops. All right.
Oh, nice.
Distance and displacement. Displacement, do you agree that we want to allow positives and negatives. When I talk displacement, what's important is, did it move right? Did it move left? Did it move up? I want to know the direction of movement. And so do I use V or speed? V, okay. Displacement is about V. I want the sign. So I'm going to use V, and it's the accumulation of many velocity times time calculations. In 2 dimensions, there is no 2-dimensional displacement per se. You could say how far, if he, at time 2, how far was he from his starting position, but it's just basically a Pythagorean theorem calculation, right? So that's not usually a calculus problem, that's more of a pre-calc problem. All right, but in all cases, distance, that's where direction doesn't matter. I don't care, did you move 3 units right, or did he move 4 units left? I just want to know how far did he move, period. So direction doesn't matter, which means instead of using velocity, I use speed, okay, because I want to remove that directional component. And so distance in 1 dimension is,
Integral of absolute
but in 2 dimensions,
the arc length.
It's the integral of the speed. In both cases, it's integrating speed. Speed times time. Speed times time. Okay? They're both speed times time. All right? Notice that arc length is distance in parametric only.
You are.
Okay. If velocity is positive over the whole interval, this is a common gotcha question, but if velocity is positive over the whole interval, then they are the same. Velocity, or sorry, distance and displacement are the same.
Oh, is that right then? Like, can you say that?
What?
That it's also like speed?
Yes, that's true. That would be true. You're right. The way I worded it, you were right. Okay. In terms of a curve, a parametric curve in 2 dimensions, if they ask for the slope or the tangent line, remember the derivative of the slope of a tangent line in parametric is dy dt or dx dt. Ah, shoot. Sorry.
Keep going.
Sorry. If horizontal slope, then it's the rise. There's no rise, so y prime is 0. If it's vertical, x prime is 0. And remember to take
My team came up first. Yeah.
the concavity correctly. There's practice.
Why, yes.
dy dx. It's the derivative of the first derivative
Over dx
divided by dx dt.
Thank you.
You're welcome. Have a good day. Sorry, I'm wrong. Yes. No problem. Yes.
I think I got it.